And it's time for section 2-3, biconditional statements. So first I'm going to start you off with a definition. Definition for a biconditional statement is a single true statement that combines a true conditional and its converse. So biconditional statements are also known as the if and only if statement. And another way that we can write that, because again, mathematicians are kind of lazy, we like to find shorter ways to do that. So instead of writing if and only if, we can also write if with two F's. So if means the same thing as if and only if. So let's take a look at an example. So again, a biconditional statement is a single true statement that combines a true conditional statement and its true converse. So to form a biconditional statement, we look at the true conditional statement, we look at the true converse statement, and we go ahead and stick them together and we put an if and only if. So the conditional statement that we're given here is if the sum of two angles is 180 degrees, then the angles are supplementary. So, the P, the hypothesis of this conditional statement, is the sum of two angles is 180 degrees. And then our Q, which is the conclusion, is then the angles are supplementary. Okay, so then we look at the converse of this, which is just where we switch our P and our Q. So the converse of this statement is going to be if two angles are supplementary, then their sum is 180 degrees. So two angles are supplementary. This was our Q. And their sum is 180 degrees. That was our P. So to write our biconditional, we're just going to take our P statement and we're going to take our Q statement and we're going to put an if and only if in the middle. Pretty simple. So our biconditional for this is going to be the sum of two angles is 180 degrees if and only if the angles are supplementary. So again, we had our P in here, the sum of two angles is 180 degrees. We have our Q in here, which was the angles are supplementary. This is our P, this is our Q, and then we just went ahead and put in our if and only if to form our biconditional statement. All right, it is time for some practice writing biconditional statements. So I'm going to start off by giving you the conditional statement. You're going to find the converse of that statement, and then after that you'll write out the biconditional. So the conditional statement that I'm going to give you is, if two angles have equal measure, then they are congruent. So your job right now is going to be to pause the video and find the converse of this statement. Now that you've had some time to work on this by yourself, we'll go over it together. So your first step was to find the converse of this statement. So the best way to do this is probably to identify our P and our Q, so then we can switch them. So if two angles have equal measure, that's our P. Then they are congruent, that's our Q. So then to write our converse, we're just going to go ahead and switch them. So if two angles are congruent, then they have equal measure. So again, to form my converse, all I did was I switched my P and my Q. So if two angles are congruent, that was my Q. then they have equal measure. That's my P. So now your job is going to be to take the conditional that we started with and the converse that we just wrote, and you're going to try to combine them together, put in an if and only if, and you're going to try to write the biconditional. So go ahead and pause the video, and using our conditional and converse, try to write the biconditional statement. So now that you've had some time to work on this on your own, we're going to go over it together. So we're trying to write a biconditional statement using this true conditional statement and its true converse. So the steps to write a biconditional, we're going to take our P and our Q and we're going to put an if and only if in between them. So let's go ahead and do that. So our P was 2 angles have equal measure. And our Q was the angles are congruent. So to write this biconditional, I'm going to take my P and my Q, I'm going to put an if and only if between them. So my biconditional is going to be 2 angles have equal measure if and only if the angles are congruent. So again, to do that, I took my P, which was 2 angles have equal measure, and my Q, which was the angles are congruent, and I put them on either side of an if and only if, and I have my biconditional statement, 2 angles have equal measure if and only if the angles are congruent. So just like before when we talked about our P's and our Q's for our conditional statements, there is actually a notation for our biconditional statements. The way that we're going to write that is P, and then we have this arrow with 2 arrowheads on it, and then a Q. So the way that we say this is P if and only if Q. Or for those of you who feel lazy like me, sometimes we can also write this if and only if as an if, an IFF. So we can also say P if and only if Q. Alright, so our last task for this video is going to be identifying the conditionals in a biconditional statement. So what I mean by that is being able to take a biconditional statement and break it down into its original conditional statement and converse statement. So let's take a look at an example here. So our example biconditional is, a point is a midpoint if and only if it divides a segment into 2 congruent segments. So the way that I want to break this down, the easiest way, for me at least, is going to be to identify the P in the statement and identify the Q in the statement. And the easiest way to do that is they're usually on either side of the if and only if. So here's my if and only if, and then my P and Q are usually on either side of it. So before the if and only if, I have a point is a midpoint. And then after the if and only if, I have it divides a segment into 2 congruent segments. So I'll call this first one, a point is a midpoint. This one can be my P. And then this one afterwards, it divides a segment into 2 congruent segments. This one's going to be my Q. So I have my P and my Q. So then my original conditional statement would be if a midpoint, or if a point is a midpoint, it divides the segment into 2 congruent segments, so that's my if P then Q. And then my converse of that statement is going to be, if a point divides a segment into 2 congruent segments, then that point is a midpoint. And so that's flipping my P and my Q, and so that's an if Q then P. So it is time to practice that skill that we just took a look at. So the statement that we're going to take a look, the biconditional statement we're going to take a look at is two numbers are reciprocals if and only if their product is 1. So your job right now is you're going to identify the P and the Q in here, and you're going to write out the original conditional statement and converse statement. So go ahead and pause the video and do that. Now that you've had time to work on that on your own, we're going to go ahead and go over it together. So like I said, first we identify the P and the Q, and usually those are just on opposite sides of my if and only if. So there's my if and only if, and so I have two numbers are reciprocals. We'll say that's my P. And then if and only if their product is 1, we'll call that my Q. So then my original conditional statement is going to be if P then Q. So that means that it's going to be if two numbers are reciprocals, then their product is 1. And then the converse of that statement is going to be if Q, then P. And so that statement would be if the product of two numbers is 1, then those numbers are reciprocals.